Okay, but how does that relate to two-digit divisors? As you'll see, two-digit divisors force us to take bigger steps. To see what I mean, let's try solving two new division problems that have the same dividend as before, but two new divisors. And both of these are two-digit divisors. In this first problem, we could start by asking how many 24s will fit into 5. But since our divisor now has two digits, we already know that no one-digit chunk of the dividend will be big enough for that to divide into. So, because we have a two-digit divisor, we automatically need to group the first two digits and ask how many 24s will make 52. This is trickier because multiples of 24 are not on our multiplication table. Instead, we have to figure it out by estimating or good guessing. Because we know that 2 times 25 would be 50, 2 is a really good estimate for the first digit of our answer. 2 times 24 is 48, and then when we subtract 48 from 52, we get a remainder of 4. Okay, so far so good. We've already dealt with the first two digits of the dividend, so now we bring down the last digit to join the remainder and ask how many 24s will make 48. That's easy, it's 2 again, because we just saw that 2 times 24 is 48, so that will leave no remainder. So the answer to this first two-digit divisor problem is 22. Now let's have a look at the next problem. It's also got a two-digit divisor, so we'll start the same way. We'll start with a two-digit chunk of our dividend and ask, how many 88s will it take to make 52 or almost 52? Uh-oh, see the problem? Even though both are two digits, this won't work because 88 is already greater than 52. And that means we're going to have to take an even bigger chunk of this dividend. We need to group the first three digits together. But that's just like doing the whole problem at once without breaking it into any steps. Yep. And that's why division problems with big divisors can get difficult. When you have a 2 or 3 digit divisor, each step might be as big as the whole long division problem, and it can take a lot of trial and error to figure it out. In fact, if we had our way here at Math Antics, when division problems get that complicated, we'd just let students use calculators to solve them. What do we want? Calculators! When do we want them? Whenever we have long division with 2 or more digit divisors! Okay. But what if we don't get our way and you need to solve this problem without a calculator? What's the best strategy? Well, a little estimating will help us make much better guesses at our answer. The numbers 88 and 528 are kind of hard to work with. But if we made estimates of those numbers, like if we changed them to 90 and 500, that would make it easier to estimate the answer. Since 100 would divide into 500 exactly 5 times, that means that 90 will divide into 500 at least that many times. So let's make 5 our first estimate for the answer. To check to see how good that estimate is, we multiply 5 by 88 and then subtract that from 528 to see what the remainder is. Now, 5 times 88 is kind of tricky on its own, so you may want to use scratch paper to work it out. 5 times 88 is 440, and when we subtract 440 from 528, we get a remainder of 88. Looks like our estimate was too low. Whenever the remainder is greater than or equal to the divisor, it means we underestimated the answer. In fact, since our remainder is equal to the divisor, it means we could have divided exactly one more 88 into 528. So we should have picked 6. And if you multiply 6 times 88, you'll see that it's 528. So as you can see, even though the division procedure is basically the same in all these cases, the value of the divisor makes a big difference on our division steps. Whenever the divisor is bigger than the part of the dividend that we're trying to divide, it means that we need to group more digits and take bigger division steps. Let's try one more, much longer, two-digit divisor problem. 817,152 divided by 38. I'm going to work through this kind of fast, so you may want to rewatch it a couple times if you have trouble following it. Since we have a two-digit divisor, we start with the first two digits of the dividend and ask, how many 38s will it take to make 81? Again, we're going to use rounding to help us estimate the answer. 38 is close to 40, and 81 is really close to 80. And since 80 is 2 times 40, my estimate for the first answer digit will be 2. 2 times 38 equals 76. And 81 minus 76 leaves a remainder of 5. We know our estimate was just right because 5 is less than our divisor of 38. Now we move on to the next digit. We bring a copy of it down and combine it with our 5 and ask, how many 38s will it take to make 57? That one's easier to estimate, just 1, because it's easy to see that 2 38s would be too big. 1 times 38 equals 38, and 57 minus 38 leaves a remainder of 19. On to the next digit. We bring down a copy of the 1, and now we ask, how many 38s will it take to make 191? That's a bit tougher. To estimate, I'll round those numbers to 40 and 200. And I know that 5 40s makes 200, so 5 is my estimate for the next answer digit. 5 times 38 equals 190. And 191 minus 190 leaves a remainder of 1. Moving on, we bring down a copy of our next digit and ask, how many 38s will it take to make 15? Uh-oh, 15 isn't big enough to be divided by 38. But don't worry, we already know what to do when this happens. Whenever we're trying to divide a bigger number into a smaller number, we just put a 0 in the answer line and move on to the next digit. We bring down a copy of the 2 and combine it with our remainder of 15. Now we ask, how many 38s will it take to make 152? To estimate this one, I'm going to round those numbers to 40 and 160. And since 4 times 40 equals 160, I'll put 4 in the answer line as my estimate. 4 times 38 equals 152. And 152 minus 152 leaves no remainder, and we're done. Wow, that was a lot of work. But did you see how much rounding helped us out? We made good estimates each time by rounding the numbers we were working with. All right, the answer to 365 times 24, not 3.65 times 2.4. So it's time to stop pretending. To get the correct answer for the decimal problem, we've got to understand what's going on with those decimal points and why we just pretended they weren't there. The truth is, when we pretended that the decimal points weren't there, what we were really doing is pretending that they had been shifted until both of our numbers became whole numbers. Remember, the numbers 365 and 24 technically do have decimal points. They're right there next to the ones place. We just don't need to show them since there aren't any decimal digits. So, by ignoring the decimal points, what we were really doing is mentally shifting the decimal points to the right. We shifted the top decimal point 2 places to the right, and we shifted the bottom decimal point 1 place to the right. But doing that changed the numbers. It made the top number 100 times bigger than the decimal version, and it made the bottom number 10 times bigger. That's because every time you shift the decimal point 1 number placed to the right, it's like multiplying by a factor of 10. And that means the answer we got is way too big. It's too big by 3 factors of 10, because the decimal points in our problem got shifted a total of 3 places to the right, 2 on the top and 1 on the bottom. So to fix that, we're going to have to shift the decimal point in our answer the same amount in the opposite direction. In other words, we need to move the decimal point in our answer 3 places to the left, which will make it smaller by 3 factors of 10. So, starting right here, where the decimal point would be if our answer was 8,760, we shift it 3 places to the left, and we end up with 8.760, or just 8.76. And that is the answer to 3.65 times 2.4. That's a cool trick, huh? It means that you can do decimal multiplication just like regular multi-digit multiplication. You start by setting up your multiplication problem exactly like you would if the decimal points were invisible. But don't just erase them, because you'll need them at the end to figure out how many places to shift the decimal point in the answer. Then, keep ignoring the decimal points while you follow the multiplication procedure. Once you have an answer, count up how many places the decimal points are shifted in the problem you're working. Don't forget, it's the total shift of both the top and bottom decimal points. And then, shift the decimal point in your answer to the left that same number of places. So decimal multiplication turns out to be not too bad after all. But what about decimal division? That's gotta be hard, right? Well, multi-digit division is always a little hard, But luckily, decimals don't really make it very much harder. In fact, it's only when there's a decimal divisor that the procedure is a little different. If you just have a decimal dividend and the divisor is a whole number, it's really simple. That's because you can just do the long division procedure that we learned in the long division videos, and the decimal point doesn't affect it at all. You just need to make sure that you bring a copy of the decimal point up into the answer line when you're done. So, if you have the division problem, 12.64 divided by 4, you would follow the division procedure as if the decimal point was not even there, and you'd get 316 in the answer line. But then, you need to bring a copy of the decimal point straight up into the final answer, making it 3.16. That's all there is to it, if it's only the dividend that's a decimal number. But what if both the divisor and the dividend are decimals? Like, what if you have to divide 6.45 by 1.5? Well, the first step is don't panic. As you'll see, this isn't much harder. It turns out that there's a very simple trick that we can use to make it so our divisor is not a decimal number. We can just shift the decimal point in the divisor to the right until it's a whole number. But if we do that, then we also need to shift the decimal in the dividend the same amount to the right. So in this case, if we want to shift the decimal point in our divisor one place to the right so that it's 15, we can do that as long as we also shift the decimal point in the dividend by the same amount, which will turn it into 64.5. And here's the really cool part. If we do this new division problem, 64.5 divided by 15, we'll get exactly the same answer we would have if we did the problem 6.45 divided by 1.5. That only works because we shifted the decimal point in the divisor and the dividend by the same amount in the same direction. And you'll realize why that works if you remember equivalent fractions. Think about the fraction 1 over 2. That's the same as 1 divided by 2, right? Okay, but what if I multiplied both the top and bottom number by 10? That would give me 10 over 20, which is equivalent to 1 over 2. Even though it uses different top and bottom numbers, both represent the value 1/2. They're equivalent fractions. Well, that's what we did in our decimal division problem when we shifted the decimal point in both the divisor and the dividend by one place. We multiplied each number by 10. And since fractions and division are basically the same, we made equivalent division problems. But now, one of them has a whole number divisor. Pretty cool, huh? That means if we solve 64.5 divided by 15, we get the answer 4.3, which is exactly the same answer we would get if we did 6.45 divided by 1.5. And you can use that trick to avoid ever having to divide with the decimal divisor, even if the dividend is a whole number. For example, if you have the problem 148 divided by 1.6, you can shift the decimal in both the divisor and the dividend one place to the right. Remember, there's always a decimal point even in a whole number. It's just that when you shift it to the right, you need to put a 0 in the place that it shifts past. That gives you the equivalent division problem, 1,480 divided by 16. And since these division problems are equivalent, you'll get the same answer for both. All right, so that's how you can modify all the traditional arithmetic procedures to work with decimal numbers. It can be a little tricky at first since there's a few extra steps that you have to keep track of when the numbers are decimals. But if you practice a lot and check your answers with a calculator, you'll get it. Remember, you can always re-watch this video if you need to, along with the other videos about multi-digit arithmetic. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.